Okay, so for the area of the parallelogram, we went through this yesterday and we found that the area is given by the base times the perpendicular height. The way we find the perpendicular height is similar to that of the triangle, where after you have decided on the base, you go to the opposite side. In this case, you can choose any point, drop a perpendicular line down. Okay, and that will be our perpendicular height. Oh, who's that? Okay, so here we have only one length given for the parallelogram. So we have no choice but to definitely use this piece of information. And after we have chosen this as the length, we go to the opposite side, this line over here. You can choose any point over here, you drop a perpendicular line down. Okay, suppose you choose this point, you draw a perpendicular line down. We need to find out this distance. We actually have it. It is given, this distance is the same as this 6 centimeters. So this will be the perpendicular height if 8 cm is the base. So the area is simply 6 times 8, and we get 48 square centimeters. Okay, next question, next page. Question 4. So now we have another parallelogram. They tell us that AB is parallel to DC. Definitely they have to be parallel, otherwise it wouldn't be a parallelogram anymore. They give you the dimensions. DC is 20 centimeters. Now, in your diagram, where else is 20 centimeters? Okay, put it down also. In the diagram, since you know it's 20, put it down as 20 cm. It might be useful for us later. Then they tell us that BC is 17 cm. What should we do with this 17 cm? Yes, draw it here also, 17 cm. So we have the complete picture right now. Okay, then you notice that they give you a dotted line over here. This dotted line, x centimeters, it is perpendicular to DC, right? Look at this right angle symbol over here. It is perpendicular to DC. This tells us that if I choose DC as the base, then x will be my perpendicular height. So if I multiply 20 to x, that will be my area. Okay, so and then we have it. We have answered part A already. The area of the parallelogram in terms of x. Area equals to the base 20 times the perpendicular height. Today they tell us the perpendicular height is x, so I have to put down x. If they tell me that x is, for example, 15 centimeters, then I'll take 20 multiplied by 15. Okay, so now the area, we have to put in the units as well. Square centimeters. Now we move on to part B, where we have to find the perimeter. So whenever you have to do perimeter, just make it a good habit, just outline the perimeter so that you do not miss out any part of it. Okay, and now we're going to add all these things up. We're going to add all these values up. Perimeter equals to, okay, for those of you who have actually just calculated 20, 17, 17, 20, make sure you write what you are calculating. Tell me what you're finding. Make sure you have this word, perimeter equals to. Do not just give me 20 plus 17 plus 20 plus 17 equals to 24. No, are you sure? Is it 74? Oh yeah, 74. If you just give me 74 cm like this, I do not know what you're doing. You have to tell me perimeter equals to. Now it becomes complete. Okay, finally, part C. Find the perpendicular height x if the area is 100 square centimeters. We refer back to our answer for part A. We actually found the area, but it was in terms of x. For different x values, we get different area, right? If x is equal to 1, then the area is 20 times 1. If x is equals to 2, then the area is 20 times 2, so on and so forth. Now, they tell us that the area is 100. They want you to work backwards to find x. So we can state that the area, we copy down whatever was in part A, 20x. And we say that this is at the same time equal to 100. Does this make sense? It's the same area, right? 20x equals to 100. Can you tell me what x is now? 100 divided by 20, yes. Whatever we do on one side, we have to do it on the other side. So we have divided by 20. Divided by 20. So we are left with x. Here we have x equals to 5 cm. Okay, and your final homework question. Who needs more time to copy this for corrections? Okay, make it fast. Then in question 5, we are dealing with a trapezium. Area of a trapezium. How do we find out the area of a trapezium? Ahmad, done? So here we have a trapezium. We say that the area is given by half multiplied by the sum of the parallel sides times the perpendicular height. Again, the idea of a perpendicular height is important. Yes? Any questions? So once you have chosen this as the base, the perpendicular height, you go opposite at any point you like, drop a perpendicular line off, that is our perpendicular height. So we are given the following information. It's a trapezium. ADE is a right angle triangle. So it is good practice. Just trace it out. ADE is a right angle triangle. EC 14 cm. BC 5.5 cm. AB to EC 5 to 7. AB to EC 5 units to 7 units. So it corresponds with the diagram that EC is longer than AB because AB represents 5 units, EC represents 7 units. Okay, now find the length of AB. AB to EC. We are told that this is 5 to 7. Now the distance that we have for EC is given to be 14 cm. So what should be placed over here? 10 what? 10 cm, yes. It has units. So actually you can do this mentally, right? From here to here you multiply by 2. Then here we also multiply by 2. So AB, part A, 10 cm. Now to find the area, since we had that already, put it down. Find the area of the trapezium. Half times the sum of parallel sides times the perpendicular height. The parallel sides, EC plus AB. We have those two values. Where is the perpendicular height? How do you know? Shouldn't this be the perpendicular height, AD? Is this the perpendicular height? Yes or no? Yes, it is. But is this also the perpendicular height? Yes, it's the same thing. So this is also 5.5. Part B, area. Half multiplied sum of the parallel sides. You look at this trapezium, only 2 lines are parallel. The other 2 are not parallel. So you choose 14 plus 10. Multiplied by the perpendicular height of 5.5. Key it carefully into your calculator. 0.5 times 24 times 5.5. 66 square centimeters. Okay? And then finally for part C. Triangle ADE is removed. Okay, let's take this away. Find the perimeter of the remaining figure ABCD. ABCD. Highlighter. A, B, C, D. Join it back up to A. We have removed the triangle already. Now do we have all these lengths? We're missing one of it, right? AD is missing. But we earlier said that it is the same as BC. What shape is this anyway? What is this shape? Rectangle. So 5.5 cm here. Perimeter. 10 plus 5.5 plus 10 plus 5.5. Oh, thank you. 21 cm. Oh, 30. You 31 cm. Quite doable. Okay, then let's move on to the start of this worksheet, where we have to do with circles. Okay, so I wanted to tell you about this. Talk to you about this question first. Here, this diagram shows two concentric circles. Wow, what is this word? What does it mean? Based on the diagram, what do you think it means? Two circles? Yeah, two circles in a diagram, but what is so special about concentric? I also have two circles here, right? So how is this different from this? Any suggestions? I can't tell who is talking because your mask cover your mouth. Okay, I exaggerate further. How are these different? What's one keyword? Starts with C. Oh, okay, concentric. Another word, circumference, no? Another one? Quite a short word, 2 syllables. Center of the circle. Okay, where's the center of the circles? The center of this circle is over here, the center of this circle is here, here, and here. But what about this? This right at the center, they share the same center. Okay, so that's what this means. They share the same center. Then they continue to tell us that the radius of the bigger and the smaller circle is 10 cm, 7 cm respectively. So 10 cm will be the radius for the big, 7 cm radius for the small. And it corresponds to the diagram. Then calculate the area of the small circle. Okay, part A. Area. What is the formula? Is it pi r squared or 2 pi r? Pi r squared. The one that has a square will have units of cm squared. So this has to be the one. So pi r squared. The other formula is 2 pi r. So do I square? Do I square, then the units will be cm or meters or kilometers. So this will be the formula for circumference. Okay, so here, do the substitution. Pi, radius of the small circle is 7 square. So we get 49 pi into your calculator. 49 pi. 153.938. And it actually continues on and on. But I'm not going to write so many digits, so many numbers. Now, by the default, round off to how many significant figures? Aloysius, what's the 3SF for this? What's the 3SF value? 154 square centimeters. Okay, correct. 153 point? How do you get 153.86? Cannot. Your calculator got pi. You must use the calculator pi. When you use 3.14, it is not exact. Okay? It's not a good enough estimate. Your calculator value of pi, look, so many digits. This is better. Part B, find the shaded area as a percentage of the big circle. Do you understand the question? Shaded area as a percentage of the big circle. So what do we need to find over here? We need to find the shaded area. Okay? But let's say I managed to find the shaded area, then what do I have to do with it? Percentage, yeah, okay, so percentage will have a fraction. Something over something that's 100%. So if we want the shaded area as a percentage, in my fraction, this will be the shaded area. But divided by what? Total area, yes, the big circle. So this will be the big circle area. Okay, so this is our plan. This is a fraction only. Then after this, we still need to multiply this by 100%, right? Then that will be our answer. Okay, now, we break the problem down into a few more parts. Shaded area and the area of the big circle. Which one easier to find? Area of big circle, yeah, we have the area, we have the radius, right? So pi r square again. Can you mentally tell me what is 10 times 10? 100. So 100 pi. This will be 100 pi. Now I got the area of the big circle. I've got another problem. How to find the shaded area? Can you see that the big circle minus small circle, then we get a shaded area? So we can do that, right? Okay, so we actually can solve this already. Percentage equals to, so you can, like I said, I don't want to just have calculation, you must tell me what you're doing. So here we are trying to find the percentage. First we wanted to find the shaded area. So we say the big area minus the small area. The big area is pi r squared. That's the big area minus the small area. The small area we've got actually a few different choices. Is it a good idea to use 154? This is the small area, right? We found that earlier on in part A. And we said that this is the answer, but is this a good option to use in part B? Why not? It is already rounded off. So it is not a good idea to use 154. Is it a better choice to use this? Yes, it is. Is it even better to use this? Is it even better to use 49 pi? Yes, it is actually even better to use 49 pi because that's exact. But if you use 153.938, it is also okay because you have like 6 SF over here. Good enough. Okay, so your choice. I would choose pi and 7 squared because I'm very kiasu. I want it to be as exact as possible. Then I divide this by the big area, pi r squared, and multiply this by 100%. Okay? So we have not finished it yet. But do you know how to continue from here? Can you take a highlighter or another color pen? Highlight this over here. Percentage. You must have the percentage symbol. That I must have. Okay, start keying all this into your calculator and see what you get. Tell me, what is your answer? This is correct. Okay, let me show you everything else. 51 is wrong. 0.51% is also wrong. Now, 51% has the same value as 0.51. Let me illustrate to you. When you go shopping, they tell you 50% off. Okay, let's say you see a handphone costs $100. They tell you 50% off. So how much do you have to pay for it? $50, right? 50% off, you pay $50 for it. So it is actually, now in fraction, this 50% is equivalent to half price, isn't it? 50% is half price. How do you get half? 50 divided by 100. 50 divided by 100 is 0.5. So 0.5 has the same value as 50%. Likewise, this 0.51 has the same value as 51%. But because they wanted it in percentage, so we are not going to accept this also. We only have one answer, 51%. Okay, I'll use this opportunity to talk to you about percentage also. 100% means 100 over 100, which is 1. You know that? You know that 100% is actually 1. 25% is the same as 25 over 100, which is 1/4, which is the same as 0.25. I give you a few more examples. 37% is 37 over 100, which is 0.37. 200%, 200 over 100, which is 2. There are times when you have working and you end up with things like this. 100% represent maybe $2. Then you go on to say 20% represent 2 over 100 times 20. Then you randomly put in percentage anywhere you like, and we end up with 40 over 100, 2 over 5%. Now this is wrong. You cannot randomly choose to put in the percentage as and when you like it. You have to be very careful to note that this percentage symbol, it has meaning. All these percent, they mean over 100. Every time you see a percent, you change it to over 100, then you'll be safe. Okay, now in your calculator, did anybody get a value that is not 51% or not 0.51? You got something quite close, but it wasn't exactly the same. Anybody? There should be. There should be some of you who got something close to 51, but not exactly 51. Then what happened? The reason is because you used this value. If you use this value, then you will not get 51 exactly. If you use 49 pi, then it will be 100 pi minus 49 pi divided by 100 pi. All the pi will cancel off, then you get an exact value. Okay, next one, question 2. Please try yourself. You have 5 minutes. Okay, we have to understand the question first. Swimming pool, shape of circle, diameter 14. So here we see 2 circles again. The swimming pool has a diameter of 14 meters. So now I'm going to highlight my swimming pool in blue. This is the swimming pool. Do you all have the same understanding that this is the swimming pool? Apparently not everybody has the same understanding. So you have to make sure you understand the question, what they are trying to tell you. Swimming pool, shape of circle, diameter 14. If you thought the big circle is the swimming pool, then it is wrong. If you thought the shaded area is the swimming pool, then it is also wrong. What else? The swimming pool has a 3.5 meter path around it shown in the diagram. So I see the numbers 3.5 over here. This is the path. So people get to walk around it. And all this distance, 3.5 meters. All of this, 3.5 meters. Now can you understand what the question looks like? The diagram is supposed to look like. So calculate the circumference of the swimming pool. So outline or highlight the circumference. Circumference means perimeter. So equal to perimeter of circle. Okay, these are notes that are useful for you. As you keep using them, you keep telling yourself the same thing over and over again, you will learn. So I want to find the rate distance. We've got a formula that we can use. Part A, circumference. The formula is 2 pi r. Some of you memorize this as pi d. They are the same thing because 2 times of the radius gives us the diameter. Okay? So we can write this is 14 pi. If you want to find the radius, can. 14 divided by 2, you get 7. Then after that, 7 times 2, you get 14 again. Then you multiply by pi. You get the same thing, 14 pi. So we need to find out this value and round it off. 43.982. So that's 5 SF. Round it off to 3 SF. 44.0 meters. So take note, we want to round this off to 3 SF. So we find, okay, 4 is my first SF, 3 is the second, 9 is my third SF. So I look at my fourth SF, which is an 8. So I need to increase 9 by 1. Once it goes up by 1, 9 becomes 10. So with a 0, and I increase 4 by 1 to get, increase 3 by 1 to get 4. So this 0.0 must be included. So highlight this 0.0. It must be included. So this is in 3 SF. So next, calculate the area of the swimming pool. After we have shaded it, I think it's quite clear. Part B, area is pi radius 14 over 2 square. So this is actually 49 pi. Calculator will give us the value again. 153.938. So round off to 3 SF again. 154 square meters. And finally, for part C, it is actually a very similar question to the previous one. Area of the path. So the shaded region will be the area of the big circle minus the area of the small circle. Area of path. So the big area we found already. No, we haven't found a big area yet. But a big area is also a circle. So the formula will be pi radius. Now what's the radius of this big circle? How much? How do you get 10.5? How do you get 10.5? Why did Eldrick say it's 10.5? Okay, so I think some of you have got it already. This is the center. I want the radius of the big circle. So join them up. This distance, 7 plus 3.5. That's how they got 10.5. Okay, so this radius is 7 plus 3.5, and we square it. This is the area of the big circle, so we need to subtract the area of the small circle, pi 7 squared. Okay, then you can put some notes over here. This is the area of big circle. This is the area of small, or rather of swimming pool. then you will know, you will remember what you are doing over here. So let's carry on. 10.5 square minus 49 times pi 192.422. So parameter, I'm still not seeing everybody write down all these keywords. You are still just giving me numbers only, which is not good enough. So you must state what you are calculating. Parameter 8 plus 22, 24, 22. (76 cm). Okay, then the area. Half times the sum of the parallel sides. So 24 and 8 multiplied by 16. So we see that this 22 over here and this 22, they are irrelevant for finding the area. What we need to find the area will be 8, 16 and 24. So the area over here we have 256 square centimeters. So next, question 7. So I just told you that this cannot be 8.8. This should be a bigger number, let's say 10. So they tell us that BS is 3.3. So to find TA, TA has to be 10 cm minus 5.6 minus 3.3. One more. Okay. Not drawn to scale. Okay, not drawn to scale. Because it doesn't make sense that this is larger. I mean, this value is smaller than 3.3. So this is not drawn to scale. Now let's move on to part B. Find the area of the trapezium QRSAB. QRS. That's not even a trapezium. QRS A cannot be AB ma. What do you want it to be? QRSAT or QRSA? Okay, Q. Let's make this Q. No, doesn't make sense also, right? QRSAT. Okay, so now we want the area of this big trapezium, okay? I hope you all realize why originally QRSAB didn't make sense. Because QRSAB is not a trapezium. It's not even a complete figure. So part B, area. Half times the sum of the parallel sides, 10 plus 5.6 multiplied by the perpendicular height. Go opposite, drop down, 5.1. Okay. 39.78 square centimeters. Should we round up to 3SF? Need or not? No need. This is exact. See? 4 numbers copied down exactly. No need to round up. Okay, now question 8, triangles. Please do this yourself. Now, for a right angle triangle, if I tell you that this is a right angle triangle, I have to tell you it is a right angle triangle first. with the following sides. According to Pythagoras' theorem, it says that in this case, a squared plus b squared will be c squared. Now, is this familiar to you? Some quick examples. If a has a value of 3, b has a value of 4 cm, what is c equal to? Okay, so let's do the substitution. A squared. So you have 3 squared, copy down, plus b squared, so 4 squared, equals to c squared. And I want to find c. So I can use my calculator for the left hand side, isn't it? So 9 plus 16 is 25. So what is c equal to? Yeah, square root 25. And what is that? 5. So when I give you a right angle triangle, I tell you this side is 3 cm, this is 4 cm. C, you have no choice, it has to be 5 cm. Okay, you get how this works? Who feels that this is the first time seeing this? No, okay. Did your teacher tell you why this is true? Did your teacher tell you why it is like this? No. Do you want to know why? Let's try. Okay, this is a square. I'm going to draw another square inside here. I'm going to draw another square. Okay, so I've got a square and a square. So these lengths are the same. Then got a bigger square on the outside. I'm going to give it some names. Let's call this short. This distance over here, let's call it A. So by symmetry, this is also A. This is also A. And this is also A. Okay? Then let's call this distance over here B. And this is also B, this is B, and this is B. So far, okay? How many triangles do you see in this picture? You got 5. How many triangles are there? 4, right? What kind of triangles are these? Right angle triangle, good. So it is a right angle triangle because this is a square. Okay, now, this smaller square, let's call the side C. So all of them are C. Make sense? Okay, now what is the area of the big square? Area of big square. So the area of a square is given by the length times the breadth. What is the length of one side? Is it AB or A plus B? A plus B, okay. So that is A plus B. And then the other side, oh, it's also A plus B. A plus B. So we can draw a rainbow to expand everything out. A square plus AB plus BA, which is the same as AB, then you plus B square, which is the same as A square plus 2AB plus B square. So this is the area for the big square. Now the area of this big square is also the same as area of small square plus, see the area of the small square, plus 4 triangles, right? And these are the same 4 triangles. Area of 4 triangles. So let's work this out. Area of the small square is given by C squared, C times C. Then you plus 4 times of the area of the triangle. These are the same triangles. So half times the base B times the height A. So this is simplified to become C squared, 4 and 2 can cancel, plus 2AB. So the area of a big square, is A squared plus 2AB plus B squared, which is the same as C squared plus 2AB. These two are the same because they are both areas of big square. Well, what can we do with that? Let's put them together. On this side, A squared plus 2AB plus B squared is equal to C squared plus 2AB. Because these two are the areas of the big square. So you see, I've got 2AB over here, I've got 2AB over here. I can remove both of them. I can subtract 2AB on both sides. So when I do so, I'm left with A squared plus B squared equals to C squared. And then, that's our Pythagoras theorem right here. This is one way to derive the Pythagoras theorem. It shows us that when we have a triangle over here with the dimensions A, B and C is a right angle triangle, A squared plus B squared equals to C squared. Okay, show it by using the area of squares and triangles. All these things, you know how to do them. It's just how you put them together only. So let's use this knowledge to work on this question. Calculate the length of CD. This is CD. We are given this distance. We can find AC. Can you see that this is a right angle triangle? ACD is a right angle triangle. So if I draw it out, ACD, this being 13 cm, this is 20 cm, then what is this? So by Pythagoras theorem, 13 square, the short side, you square it, plus the short side, you square it. So CD is what we want to find out. CD square, it is going to give us the long side square. This is our Pythagoras theorem. The sum of the squares of two shorter sides equals to the square of the longer side. So CD square is 20 square minus 13 square. So CD will be the square root of 231. To find this distance B to D, we have another right angle triangle. And we already found out CD. CD has a value of square root 231. I did not use 15.2 because that is rounded off. Square root 231 is the most exact over here. Okay, so using Pythagoras theorem again for part B, the shorter side, you square it, so 8 square, plus the other short side, square root of 231. That's the distance, and we square it. What happens when you square a square root? They cancel off. When you square a square root 231, we get 231 as the answer. So Pythagoras theorem tells us that this is going to give us BD squared. Okay, so let's work this out. 64 plus 231. 295. So BD squared equals to 295. BD must be square root of 295. 17.175. So round it off, 17.2 cm.